Hello, everybody. Thanks for coming in. Uh, so today's session is really about, accelerating how you build data foundations to enable AI, and uh, this is something that we as Tiger Analytics have been working on for a while, working closely with Databricks, and our clients to enable. Uh, I'll just do a small pit stop who Tiger Analytics is. We are a professional services organization, niche data and AI service provider. We are a Databricks elite partner, have about 120 plus Fortune 1000 clients that we work with across building AI data science models, operationalizing them, doing building data foundations for for analytics, etc. About 5,000 plus engineers, data scientists across the globe. We all know about the GenAI hype. AI is truly being hypercharged by GenAI, and what we believe is open foundational models are at the core of this, but they can do a lot. But what they don't know about and don't have the context around is your data, your product data, inventory data, etc. And in order to make Gen AI really thrive in your use cases in the enterprise, you definitely need to enable many different components to be able to provide that context to these LLMs. Uh, everybody is trying to do this foundational LLMs, doing prompt engineering, building on top of your data models, on top of LLMs, fine tuning it, even building custom LLMs. But none of this is possible in an enterprise setting without a proper data foundation. Right? And building a data foundation involves many different things, everything from building your semantic layer, making data consumable, making data governed, observing how your pipelines are doing, etc., making it truly, something that can be sustained and AI can depend on. This is hard and time consuming. If you look at the entire process that a data engineer goes through in enabling, a data analyst, engineer, your data organization goes through in enabling, data for consumption for AI, it's a big process. Everything from building an understanding for data, preparing the data for consumption patterns, governing that data, and then operationalizing and monitoring that data. Right? This is hard, time consuming, but very well worthwhile, right? But how can we accelerate this entire process from taking weeks and months to a shorter time, right? This is critical to what we believe is in unlocking the value of AI in the organization. So we look at data management, data operations, data governance as processes. And what we have done is identified how can we be co-pilots to various stakeholders in an organization, practitioners who are building models, who are building data understanding, who are doing data governance, supporting existing pipelines, as data flows through, governing the data as it's landed, as it's consumed. How we take each of these as processes and enable co-pilots specific to enable those human agents to reduce their cognitive workload. Right. So we have looked at multiple different areas around, exploring data, how to build that data understanding, how to enrich your data, how to build the data, and we've built toolkits, small utilities powered by GenAI, powered by, in some cases, foundational LLMs, in some cases, fine-tuned, really well thought through, guardrail-enabled capabilities. And I'll walk you through some of these capabilities in each of these use cases. So for example, one of the capabilities that a lot of our clients are using today is in enabling their data modeling capability. So we have created an assisted data modeling capability. This is also something that we have created for enabling enterprise data architecture teams as well. And what we do is we basically provide to to this utility your enterprise data standards, your data modeling standards, etc. What the utility takes as an input is your data, builds an understanding of that data, and what it does is it reduces the time from going from building that understanding to creating that first initial data model, just from understanding the data, from probably a few weeks to less than a few days. And this is a huge uplift in the efforts to actually actionizing that data, right? Beyond generating that initial understanding of data, what you can do is provide in English language understanding of the end goals, end KPIs that you want to activate for your clients, for your dashboards, for your end consumption. And what the utility will do is it will enable you to, it will capture that understanding, combine it with its understanding of your enterprise knowledge landscape and the data standards, and build an enterprise, a logical data model that you can take and actually actionize, right? It actually creates these, it creates the underlying structures, it creates actual structures and actual code that you can then take and convert into PySpark, right? In terms of taking from source to modeling it into a common data model and then actionizing it into the KPIs, right? End to end, we can generate that. In order to do this, we have used foundational data models to make this happen. And just a little bit about the process, right? This image there, it's the most simplified thing that we have done just to show you. We basically utilize a vector store, in this case the Mosaic AI vector store, vector search engine, and LangChain and foundational models to and put guardrails and put chain of thought patterns and prompt engineering around it to to generate this. It's it's well thought through. It requires a lot of tweaking and understanding to reduce the hallucinations and reduce the imperfections. But the good thing is that it's enabling your enterprise data modeling teams, your data analysts to work faster, right? In the data operations space, we have looked at various capabilities in enabling your data operations, which is basically, looking at your, enhancing your data or correcting your data, working with FinOps in understanding what are your storage costs, what are your, compute costs, and optimizing those. And in the area of AI ops, in enabling observability, right? So we have built several tools. For example, this is a process that we enabled for one of our clients, where we are basically taking, a log, their enterprise data logs, and finding patterns within that log, baking the logs into patterns that we discover, and then doing that data collection, processing those logs and deriving insights out of that, right? So that getting to a point where you can interact through from unstructured, semi-structured logs to making it structured, so that you can interact and ask questions of the log. So, for example, you can ask questions, about. This is an example of logs that we captured from data flow and from Azure data flow that we captured. And this is an example of actually asking human questions about the logs. And not only that, the agents can go and self-analyze and bring recommendations on what is actually happening, correlating various logs, etc. Right? So this is an example of asking about, give me the job name-wise error count. Right? So it goes and figures out, first of all, what would be the relevant log that will have this information on its own without you prompting it, and find this information and determine the right kind of visualization to picture it out, right? So if you want to know what kind of failure reasons, top 5 failure reasons, etc., the tool will be able to go and query. So we have basically combined historical log processing with our text to log querying capability to basically make the operations person's life easier, right? There's another capability around active log monitoring where we have it's a little bit more advanced, where we have built customized, fine-tuned fine-tuned LLMs. We have basically fine-tuned Llama 2 in giving it the ability to process semi-structured logs, identify patterns, and come out with anomalies in near real time. So imagine every log that is coming in, we are able to put this engine on top of it, and without any pre-baked understanding of that log, we are able to derive insights for you in near real time. The reason why we have chosen to fine tune and use not use a foundational LLM is for cost effectiveness of such an operation. As you can imagine, you can have billions of logs that you could be processing, and if you pass this through something like an OpenAI, that will be a very, very expensive proposition. So we have quantized, we have really optimized this kind of log baking process and been able to cut down that cost to a point where it is economically viable to do this kind of an activity, right? So this is just an example of being able to look at the logs, generate basically being able to generate specific recommendations coming out of the log and alerts out of it, right? An example in the data governance area where we have created utilities around, one of the key things that data governance organizations need to do is create an understanding of data quality in your data. What we took it as a challenge was not just understanding the very basic data quality, but when data is highly processed, coming in from various data sources, it's highly integrated, the data quality takes up a different meaning. It's closer to the context of consumption. And really, to understand from a data scientist standpoint, or from a from a person who's building a dashboard or a KPI, what that data quality could mean, what we have done is, I'm sorry, what we have basically done is created a bot that will go in using LLMs that parses, profiles the data, but then creates microsegments and understanding of the data at the microsegment level. So you will understand how your data is behaving by geography, for instance, by a location dimension or by a product category dimension, rather than at a global level, right? Which may not be all that useful, right? So you may have from certain geographies, because of because of regulatory needs, you may need to enter certain amount of data. So the LLM kind of recognizes that there is difference between various geographies. So it microsegments it, understands the profile at the microsegment level, and comes up and creates basically data quality rules at that level, which we can then convert into great expectations code. Right. This is an example of that, where you can create these microsegments and create anomaly data frames, where at a microsegment level you can determine whether a particular KPI is showing anomalous behavior. Yeah. So the approach that we have taken to building each of these capabilities is basically we have leveraged foundational models wherever we can, leverage locally deployable models where cost considerations come into play, where there's large volume of data to be profiled, to be processed, make it as easy to consume as possible, low code, no code, prefer open source, cloud agnostic capabilities that can be deployed anywhere, and use most importantly, use guardrails and understanding of the client's environment to train these LLMs, right? So we use, for example, Anthropic or OpenAI as our as the foundational models to build these co-pilots. And in the open area, we are using DBRX and Llama 2 models. We're using Mosaic's vector search, and in some cases, where there's high volume, high throughput required, Redis vector search as well. We're using Mosaic's agent framework for complex scenarios where multiple different LLMs need to be orchestrated across, and then also utilizing the compute framework within Mosaic to enable this. Any questions? Please feel free to ask. Would be more than happy to answer that. All right. There is. Sorry, I lost control of this. Yeah. So there are several use cases that we've identified and actionized. One of the key takeaways from our last 6 months of building these capabilities and applying them in our clients has been that you truly need to look at the LLM as a co-pilot, as a helper to the human process that goes on in an organization, right? So really understanding how your operations happen, how your data modeling team work, how your data stewards work, and understanding them, and then taking their guardrails and utilizing that to train these models helps in basically making this real for them, right? You can't take a very generalist approach to building general purpose models. They often tend to fall short, right? So having worked with various clients, this has been one of our biggest learnings, right? That's all for my presentation. Yeah.